Hello and welcome back to another holistic education video. In this video, we'll be continuing our series on the 25 hardest SAT math problems of this year according to PrepMaven. In this video, we'll be looking at problem number 18, which says, one of the factors of 2x cubed plus 42x squared plus 208x is x plus b, where b is a positive constant. What is the smallest possible value of b? So we'll start off by writing out this expression. We have 2x cubed plus 42x squared plus 208x. And we're going to want to factor this into three different terms, one of which is in the form of x plus b. But if we look at this, there's actually one term we can already easily factor out of it. We see that every term here has an x in it and every term is even, which means we can factor out a 2x from every single one of these terms. If we factor 2x out of 2x cubed, we just get x squared. We factor 2x out of 42x squared, we just get 21x. And if we factor 2x out of 208x, we get 104. So now we have 2x times this quadratic, x squared plus 21x plus 104. And this quadratic we can factor into terms where at least one of the terms is of the form x plus b. So this is going to equal 2x times x plus b times x plus c. And in this fact, we actually know that both of these terms are going to have positive constant values because every single term in our quadratic is positive as well. So this quadratic, x squared plus 21x plus 104, is going to factor into some two terms, x plus b times x plus c, where both b and c are positive. So what we have to do is find out what these terms are, what these constant values are, and then see which one is the smallest value, and that will be the answer to our problem. So how do we figure out what these values of b and c is, what this factors into? Well, there's a couple ways we could go about doing that. One way is we could go and try to factor this through guess and check. We could look at all of the different factors of 104, and we could see which of them add up to 21. But the more guaranteed method would be just to use the quadratic formula. So let's use the quadratic formula. In this case, we have our a value is equal to 1, our b value is equal to 21, and our c value would be equal to 104. So if we use the quadratic formula, we would get negative 21 plus or minus the square root of 21 squared minus 4 times a, which is just 1, times 104, all over 2a. We can simplify this and get negative 21 plus or minus the square root of, and 21 squared, if you put into your calculator, you'll see is 441. 4 times 1 times 104 is 416. And this would all be over 2. Now we'll continue simplifying this. Negative 21 plus or minus the square root of, and 441 minus 416 is just 25, which is nice because that is a square number, which means that this is just going to be negative 21 plus or minus 5 all over 2. And if we check the plus one, that's going to be negative 21 plus 5, which is negative 16 over 2. We get the minus one, that's going to be negative 21 minus 5, which is going to be minus 26 all over 2. And then that means that our zeros, x values, are going to be negative 8 and negative 13. This means that negative 8 and negative 13, according to the quadratic formula, are the zeros of our quadratic. But we have to remember what that means to get back to the answer we're actually looking for. Remember, if we have a 0, let's say x1, what that means is if we plug that x1 into our equation, we will get 0, which means, let's subtract our constant from both sides, that our 0 of the equation is actually the opposite of the constant value that we're going to have in our term. So when we say x plus b times x plus c, and we find the zeros, x1 and x2, of this expression, the constant values we're looking for are actually going to be the opposite. So even though the zeros are negative 8 and 13, the constant values are actually going to be x plus 8 and x plus 13. And that is, of course, because if you plug one of these values into this expression, negative 8 into here, that goes to 0, zeros out. Negative 13 into here, that goes to 0, zeros out. So that means that we can factor our original equation into 2x times x plus 8 times x plus 13. As a matter of fact, we have two different terms that are in the form x plus b. We need to find the one where b is the smallest possible positive value, and that would be this term. In other words, the b value we're looking for is 8. 8 is our final answer. Thank you so much for watching, and I look forward to seeing you in the next one.